Welcome back. Today we're going to be talking about multiplying and dividing radical expressions. This is the second part of our Module 6. A lot of this should be some review from Algebra 1, but I wanted to start out with this notion of how we can multiply these expressions. Well, we can multiply them if they have the same exponent. So if we have 2 squared and we have multiply times 3 squared, the exponents are the same, so we can multiply that as 6 squared or 2 times 3 squared. The same thing is if they have the same index, the same thing applies. So square root, so if you have the square root, so the index is here, right? So the index can be square, cubed root, etc. So if I have square root of 2 and multiplied by the square root of 3, if that index is the same, we can say that that's going to be the square root of 2 times 3. So that's the rule in multiplying radical expressions. So if I take an expression that looks like this, cubed root of 6, and I want to multiply it times the square root of 2, I can't do that. And why not? Well, the indexes are different. I've got a cubed root and I've got a square root here. So the property that we're looking at does not apply. So here's the property. I'm going to put the property right here. All right, so the property is that if the nth root of a and the nth root of b, if those are real numbers, then you can combine the nth root of a times the nth root of b, and that's going to get us the nth root of ab. But that's got to be the same in order for us to do that. So the property here does not apply. So we can't do that. However, if I have the cubed root of -4, so I've got the cubed root of -4, and I want to multiply that times the cubed root of 2, and I want to simplify it, I can do this, right? Because I've got that the index is the same, the cubed root. So that's going to get me equal the cubed root of -4 times 2. Well, that's going to get me equal the cubed root of -8, and the cubed root of -8 equal -2, right? Because I've got -2 times -2 times -2. That gets me +4 times -2 equal -8. So that's the way that we can use the property to get at what we need. All right, we've looked at radical expressions and whether or not we can simplify based on the root value or the index. Let's look at how we can simplify and then use those steps for simplification in order to get at simplest form when we have a variable inside of the index. So if we look at the square root of 24, we can say that that's equal to the square root of 6 times the square root of 4. Well, we know that the square root of 4 is 2, so therefore we have, in simplest form, we have 2 square root of 6. What about if we have the cubed root of 24? Well, we have to think about the cubed root values, and so there's not a cubed root to 6 and there's not a cubed root to 4. However, if we can think of this as 8 times 3, we can think about that as the square root of 8, the cubed root of 8 times the cubed root of 3, right? So the cubed root of 8 is 2, so in simplest form, that's 2 times the cubed root of 3, and that gets us simplest form. Now that we've gone through that, let's think about this one in simplest form. We have the cubed root of 54x to the 5th. Now, if we think about these in terms of perfect cubed values, we can think of it like this. We have the cubed root of 54. We can think about that as 3 times 3 times 3, right? That's going to give us 27. So we're going to have 27, so we have this cubed root of 27 times the cubed root of 2. And now let's take that x to the 5th times the cubed root of x to the 3rd times the cubed root of x squared, because that gets us x to the 3rd. So here's a perfect cube, right? And here is a perfect cube. So we can end up, so the cubed root of 27 is 3, and the cubed root of x to the 3rd is x. So that leaves us with cubed root of 2 times the cubed root of x squared in simplest form. So we have 2 cubed root of 3 in simplest form. Let's add just another step and look at it as a product and simplify this product. So if I have the square root of 72 x to the 3rd y squared, and I want to multiply that times the square root of 10 xy to the 3rd. So one of the first things I can do is I can multiply my 72 times 10, so that gives me the square root of 720. Now I have x cubed times x. Well, that's going to get me x cubed times x. That's going to give me x to the 4th. And then I have y squared times y to the 3rd. That's y to the 2 plus 3. So that's going to be y to the 5th. So far I have the square root of 720, x to the 4th, y to the 5th. Now, I can think of this as how can I get perfect squares out of this? And I can do that by factoring, right? So that's one of the methods I can use in factoring. So I can think about this as, if I have 12 squared, that's 144. Now, 144 times 5 is going to get me 720. So I can think of it that way. So I can think about that as the square root of 12 squared, right, times 5. Now let's break this apart. So I've got x squared squared. That's going to give me a perfect square there. And then I've got y squared squared. So that's going to give me y to the 4th. And then I've got a y left over here. All right, so perfect square here. So I've got 12. And then I've got a perfect square here. I've got x squared. All right, and then I've got a perfect square here. That's y squared. And then I'm left with, over here, I've got 12x squared y squared times 5y. So my 5 was left over, my y was left over. So in simplest form, this product is 12x squared y squared, square root of 5y. And that's going to get us simplest form. So when you're trying to do this, what you can do is you can factor. So 720, and you can create a factor tree by doing that. You can start with perfect squares. So you can go 4 goes into 720. And you can begin to build it this way, right? So once you build it this way, your factors, then you can get your greatest common factor, and then that's going to be your square root. So in this sense, we were dealing with square root, so you have to think about it in cubed values when you're thinking about something with cubed roots and so forth. So we're trying to get it into simplest form, so make sure that when you work these, you have taken it into its simplest form. So we've multiplied some of these radical expressions. Now let's look at simplifying some of these quotients. So now we're going to be using the operation of division of these, and we're going to be using some of our knowledge of fractions to be able to get at some of these. So if I have a expression 18x to the 5th divided by or over 2x to the 3rd, so we're going to do a couple of things here to simplify. So what you can see here is we've got 18x to the 5th over 2x x to the third. So what I'm going to do is I'm going to place it as one big square root, so 18x to the fifth over 2x to the third. Now, 18 divided by 2 is going to give me 9. And then x to the fifth divided by x to the third, I'm simply going to subtract my exponents. 5 minus 3, that's going to give me x squared. Now, I can simplify that. The square root of 9 is 3, and the square root of x squared is x. So here in simplest form, I've divided, and I've gotten 3x. So let's take one a little bit further again. So the cubed root of 162 y to the fifth divided by the cubed root of 3y squared. All right, so what we're going to do is going to put it all over the cubed root value of 162 y to the fifth over 3y squared. No, so the same thing. 162 divided by 3 gets me the cubed root of 54, and then y to the fifth over y squared, that's 5 minus 2, so I've got 54y to the third. So the cubed root of 54 is, I've got to simplify that. So I've got the cubed root of 54, I've got to think about that in cubed roots. So that's going to give me 3 times 3 times 3 is 27. 27 times 2 is 54. So that's going to really get me this cubed root of 27 y to the third, and then times the cubed root of 2, because I've got 27 times 2 gets me 54. Now I've got perfect cube here, so the cubed root of 27 is 3, the cubed root of y to the third is y, and then I've got left over, I've got the cubed root of 2. So in simplest form, I've got 3y cubed root of 2.